Welcome everyone. I'm Norman Wildberger, and today we're going to talk about the multiplication table. This is a rite of passage for all young people learning mathematics. We have to learn and memorize the multiplication table. Now we're going to do this in two stages. Today we're going to talk about the multiplication table from 1 to 5, and then in our next video we're going to go further from 1 till 10. Alright, so let me remind you about multiplication, one of our two fundamental operations with arithmetic. Originally we thought of numbers in a very simple-minded kind of way, so that the number 3 can be represented by those three little boxes in a row. And when we multiply 3 by 4, what we're doing is we're counting the number of squares in a rectangle. A rectangle that has 3 rows, the same number of rows as this thing has boxes, and 4 columns, the same number of columns as this one has boxes. Now, this rectangle here, we can think about decomposing it or counting it by peeling off each of the rows. So here's one group of 4, then the next row gives us another group of 4, and the next row gives us another group of 4. So another way of thinking about what 3 times 4 is that it's 3 groups of 4. We have one copy of this number for every cell in the first number. And I remind you, when we add these 3 numbers, what we're really doing is we're just putting them together to form one bigger number. And we can count what that number is: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could also have done that up here. We could have counted 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we find that 3 times 4 is equal to 12. And this is what we write or say. We use the word times to represent the multiplication operation. So again, 3 times 4 equals 12 means, or can be interpreted as meaning, that 3 groups of 4 equals 12. A group of 4 plus another group of 4 plus another group of 4 makes 12. In other words, we're adding groups of 4, altogether 3 of them together. So multiplication is repeated addition. Alright, so eventually we have to memorize this fact. Now that we've understood it, we have to memorize it. But we must memorize not just that fact, but a whole bunch of facts similar to that. We have to learn not just 3 times 4, but also what is 3 times 2, and what is 4 times 5, and so on. And we're going to try to do that somewhat systematically. In today's video, we're going to stick with the numbers 1 through 5 for simplicity. But we're going to try to organize the job of memorizing multiplication by using a table. That's the multiplication table. So here then is our multiplication table using the numbers from 1 up to 5. So this is stage 1 of learning the multiplication table. Stage 2 will be when we go from numbers 1 all the way up to 10. It looks a lot like our earlier addition table, but it has a multiplication sign here to remind us that it's multiplication that we're talking about. And there are all these entries telling us what the various products of numbers are. So for example, to find out what 3 times 4 is, we look down here till we get to the 3, we look across here till we get to the 4, and then we look at the entry in the table, which is in the same row as the 3, in the same column as the 4. Since that's 12, it tells us that 3 times 4 is 12. Let's do a few other ones. What would 4 times 2 be? 4, 2, it must be 8. So 4 times 2 is 8. How about 5 times 3? 5 times 3 is 15. How about 1 times 4? 1 times 4 would be 4. Alright, so let's have a look at these entries. They have some pleasant properties. There's some obvious patterns here that we should be aware of. First of all, each row consists of multiples of the first entry. For example, this row here, whose first entry is 3, this row consists of the multiples of 3. 3, 6, 9, 12, 15. It's what we get when we take 3, and then we add another 3, and then we add another 3, and then another 3, and then another 3. And similarly, here are multiples of 4, here are multiples of 5, here are multiples of 1. 1, 2, 3, 4, 5. The same holds for each column. So if we go down the 2's column, say, we get all the even numbers. 2, 4, 6, 8, 10. Those are all the multiples of 2. We go down the 5 column, 5, 10, 15, 20, 25. We get the multiples of 5. So if we can generate multiples pretty easily, then it's not too hard for us to generate this table, even if we're not so familiar with multiplication. It's just listing multiples. Another important observation is that the table is symmetric. By that I mean that 3 times 4 is the same as 4 times 3. This entry and this entry are the same. 2 times 4, which is here, 8, is the same as 4 times 2, which is here. So the table is symmetric about this diagonal. We call this the diagonal of the table. So if we sort of reflect in this diagonal, we get the same values. This 10 here, same as that 10 there. This 15 here, the same as that 15 here, and so on. And why is that? Well, it's because 3 times 4 is equal to 4 times 3. That's one of the fundamental laws of arithmetic. That's the commutative law of arithmetic. And let me remind you that the reason why that's true is because the number of squares in a 3 by 4 rectangle is the same as the number of squares in a 4 by 3 rectangle. The rectangles here are really the same, except that they've sort of been flipped over. Okay, we have to memorize this table. We have to understand it, make sure we know where each of these entries comes from, and then we must commit this to memory. This is an important job for young people in the grades 1, 2, 3, and so on. They have to learn how to multiply, and they have to memorize these things so that these things are just automatic. So 5 times 4 is automatically 20 without having to work it out, without having to first imagine a rectangle and sort of count. Okay, so that's an important, very important rote learning technique that has to be done. All right, now let's have a look at an interesting property of the multiplication table that might make it easier for you to memorize it and to remember it. It's what I call the rectangle property. And it's the observation that each entry of the table determines a rectangle consisting of the things which are above it and to the left. And the entry is exactly the size of this rectangle. So for example, let's look at 5 times 2 equals 10. We know that that means 5 times 2 is the number of squares in a rectangle which has 5 rows and 2 columns, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And there's the 10 right there. Now have a look at where in the table this 10 occurs. It's occurring here in the 5th row and in the 2nd column. So if you look at the portion of the table which is above this and to the left, in other words, this part right here, I'm talking about the portion of the table that's inside the green table itself, not these sort of outside ones. This inner rectangle here is exactly the same size and shape as this thing here. In other words, this 10 is actually counting the number of entries above it and to the left. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This 10 is telling us that this rectangle has 10 entries. Let's do another one. Say 4 times 4. 4 times 4 is 16. And that 16 is the same as the number of entries in that rectangle there, because that rectangle is, of course, a 4 by 4 rectangle, consisting not of squares now, but actually of numbers. So this is another way of thinking about the multiplication table, that at every point we're just recording how many entries there are in this rectangle formed by having this number in the bottom right-hand corner. So that 12 there is counting the number in that rectangle. That 6 there is counting the number in this rectangle. This 20 is counting the number in this rectangle, and so on. It's an interesting observation that, that probably you should be aware of. It's really a rather obvious observation. Some of the entries in the multiplication table play an especially important role, namely the ones that are on the diagonal, the ones right down here, 1, 4, 9, 16, and 25. They represent the products of a number with itself. So 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16, and 5 times 5 is 25. Those are called square numbers for an obvious reason. They correspond to the number of entries in a square. So here's a 2 by 2 rectangle, which is a square. Here's a 3 by 3 rectangle, which is a square. 9 entries, we've already seen that when we're playing tic-tac-toe. There's a 4 by 4 rectangle, a 5 by 5. Like a chessboard. A chessboard would be 8 by 8. Alright, so these are very special numbers in mathematics. They come up in a lot of different forms, and it's important to recognize them. So there's something special about the number 25, something special about the number 16, the number 9, the number 4, the number 1. And later when we go to higher numbers, there will be more square numbers, of course. They are special and interesting, geometrically important numbers. So if you're teaching young people, maybe your children or maybe a classroom, here's good advice, I think. Your attitudes towards the multiplication table should be that the students should first understand multiplication and what it means, and then they should memorize it. So the understanding comes first, and then the memorization follows. So for example, what is 4 times 5? The student should be able to figure out what that is by going back to the geometrical understanding. It's the number of cells or squares in a 4 by 5 rectangle. Or to put it another way, it's what you get when you take 5 plus 5 plus 5 plus 5. 4 lots of 5. So a young pupil who doesn't know that already can figure out what this is in a number of ways. He can draw a rectangle and count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Or they can say, well, we have 5, and then another 5, and then another 5, and then another 5. Okay, so first we start with 5, and then we add 5, well, that's 10. And then we add another 5, well, that's 15. And we add another 5, well, that's 20. And you may have to use your fingers to do that. It's all right. One way or the other, they should understand how to figure out what 4 times 5 is. They should have a visual sense of what it means. All right, so once you've understood what 4 times 5 is, and you know that it's 20, then at some point you have to let go of this way of calculating it and just go directly from the 4 times 5 to the 20. You have to then memorize that 4 times 5 is 20, so that no more thinking is involved. So you have to memorize that 4 times 5 is 20. 4 times 5 is 20. 4 times 5 is 20. If you repeat that enough times, you will learn it. You want to put it in your long-term memory, or the student wants to put it in their long-term memory. And how do we do that? Well, that's an interesting question. I would say, relatively simplistically, that one should try to memorize things like this by using a number of different ways. Read it, hear it, say it, write it, think it. Those are 5 different ways of putting it into your long-term memory. So for example, read it. You can just read this without having to say anything. Just read it. It's a mental image. It's a visual image. 4 times 5 equals 20. It's a picture. If you see that picture enough, it will stick in your mind. You can hear it. So if someone says 4 times 5 is 20 enough times, then it becomes like a song that you've heard on the radio a number of times. Eventually, it just goes into your long-term memory. You can say it. So the student can say 4 times 5 equals 20, 4 times 5 equals 20, and so on. The student can write it out. 4 times 5 equals 20, 4 times 5 equals 20. And when they're walking down the street, they can think it. Just remind themselves, what is 4 times 5? Oh yeah, it's 20. So those are different ways of trying to get the multiplication table into long-term memory. Repetition is important. And we're aiming for it to be automatic and rote. Now you might say, well, isn't that bad? Isn't it bad to do something automatically or by rote? No, it's not. As long as it's supported by understanding first. So as long as the student knows what it is that they're memorizing. It would be wrong, I think, for a student to memorize that 4 times 5 equals 20 if they didn't already know what that actually meant. If it was just some meaningless combination of words that they've been asked to memorize, that's no good. You want them to understand what it means, and then you want them to memorize it. And of course you can do this in many different ways. You can have cards, you can play games, you can ask them to write it out, you can talk about it, you can go through the multiplication table and read it. 1 times 1 is 1, 1 times 2 is 2, 1 times 3 is 3, 1 times 4 is 4, 1 times 5 is 5, 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10. If you actually go through the table like that and read it out what each entry says. 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9. You say that over 10 times, go through the whole table 10 times, and you've probably starting to understand the multiplication table. Especially if you do it again tomorrow, and then again next week. Okay, so it's a bit painful. It's maybe not that painful, but it's an important task that young people have to perform. They have to memorize the multiplication table. There's no ifs, ands, or buts about it. Okay, it's not optional. If you want to understand mathematics, the memorization of the multiplication table is compulsory. So once the student is starting to memorize the table, then we must give them practice problems so that they can use what they're learning. That makes it more interesting and makes it clear to them that this is not just some crazy game, but we're actually doing this for a purpose. So the student must go through a lot of problems to solidify their understanding of the multiplication table. For example, 2 times 3 is 6. Now, we probably know that, right? Because, well, we've memorized it. Of course, if we hadn't memorized it, we could say, well, that's really 3 plus 3. It's really 2 groups of 3, and the first 3 is that, and then one more group of 3. That would make 6. And if we hadn't memorized it, we would have to do something like that. We want the student to go beyond that to just instantly writing down the answer. 4 times 1 is 4. 5 times 2 is 10, and so on. Here's a different kind of problem. Find the mystery number. 4 times something is 12. What is the something? Well, again, if you have the multiplication table memorized in its entirety, maybe this is a little bit easier. What we can remember, so 4 times 1 is 4, 4 times 2 is 8, 4 times 3 is 12. Oh, that's the right one. So it's 4 times 3, which is making 12, so the answer would be 3. 3 times 2 is 6. Something times 5 is 5. Well, 1 times 5 is 5, 2 times 5 is 10, so it must be 1. And I'll leave the rest to you. Alright, and now let's do a few word problems involving these relatively small multiplications. So the first problem, how much is this number? Well, we could count them, but hopefully a student realizes that this is a problem involving multiplication. This is exactly the problem of multiplying 3 by 1, 2, 3, 4, 5. 3 times 5, hopefully we've memorized that that's equal to 15. So we could say the number is 15. Because we generally like to write down a sentence if the question is a sentence. How many in 3 groups of 2? So 3 groups of 2, that means 2, and then another 2, and then another 2. So we're talking about 3 groups of 2, so that's 3 times 2, and hopefully we know that there's 6. So how many in 3 groups of 2? There are 6. How many legs total in a group of 4 people? Well, one person has 2 legs, so if we have 4 people, then we have 4 groups of 2 legs. So there's one person's legs, there's another, there's another, there's another, 2 legs, 2 legs, 2 legs, 2 legs. 4 people makes 4 times 2, so it's 4 groups of 2. That's the multiplication that we need to do. And the young person has to recognize that this is a multiplication. They should draw on their memory to say what this is. 4 times 2 is 8. So we say that there are 8 legs in total. All right, a few more. What is twice 4? Well, that means 4 and 4 together. So one way of writing it might be 4 plus 4. That's using addition. And you could work it out knowing the addition table. Or another way is to recognize that that's really 2 groups of 4. So it's also 2 times 4. So we could work that out with the multiplication table that we've hopefully memorized. And it's just the same 8 as we got before, but now it's 2 groups of 4 rather than 4 groups of 2. I get 3 letters a day for 5 days. How many letters did I get? So on Monday I got 3 letters, and then Tuesday I got another 3 letters, Wednesday 3 letters, Thursday 3 letters, Friday 3 letters. We want to encourage the student to use multiplication to recognize that this is a certain number of copies of the same number added together. We've got 3 letters appearing 5 times. This is 5 groups of 3. In other words, 5 times 3. 5 times 3 is 15. And so we can say I got 15 letters. And finally, Mary invited 4 couples for dinner. How many guests did she have? Well, a couple is 2 people. And she's invited 4 couples, so it's 4 times 2. Which again is the same 8 that we had before. And so she had 8 guests. And I want you to be a little bit careful in the order of multiplication. I know 4 times 2 is the same as 2 times 4, but let's be consistent and agree that 4 times 2 means 4 groups of 2, while 2 times 4 means 2 groups of 4. So this represents 4 plus 4, while this represents 2 plus 2 plus 2 plus 2. Alright, so very basic and important skill. Multiplication, which is trickier than addition, it requires more work. So I suggest that people, young people, master the 1 to 5 multiplication table before they go on. If they get that down really carefully and well, then they're in a good position to go to the 1 to 10 multiplication table, which we're going to talk about next time. So I hope you'll join me for that. I'm Norman Wildberger. Thanks for listening.